Yes, Vinayak, you can start.
Yes, sir. I'm just. So, sir, my name is Vinayak Gupta. Currently, I'm a BCA third year student, and I have implemented one algorithm whose name is Naves Base. So, sir, firstly, sir, I have imported all those modules which I required to use in my project. So initially, this first line from sklearn.datasets, I have imported load iris. Actually, load iris are actually a data set which I would be using there, which I will be using in this particular algorithm. So first of all, I have imported this load iris data set actually. And then, sir, I have imported sklearn.model selection. From sklearn module, there is a model selection class, and from that, I have imported train test split for splitting the data set into two parts, data part and target part. Then, sir, I have imported the algorithm, like the algorithm itself, like Gaussian NB. So it is the Naves based algorithm. So it is also I have imported this. And then, sir, for finding the accuracy of the model, because we know that for any machine learning algorithm, accuracy matters the most, because after finding the whatever the data which that algorithm is going to predict, we have to find the accuracy. So for that, I have imported this as from sklearn.matrices. I have imported accuracy underscore score. Then here I have imported this load iris is a method. Load iris is a method which loads the iris data set into iris underscore data set. Now what I have done, I have kept the data part in X and the target part in Y, sir. So after this, I have here in the third cell itself. Let me run this. In the third cell itself, what I have done, I have used the train test split function, where I am storing the X train, X test, Y train, and Y test. These all are these X train and Y. Is this X train and X test are this X train is the training data on which the machine learning model would be trained, and by supplying this X test value, we would test the what the algorithm is actually predicting. And here we have separated the label part, the target part, which is within the training part, Y underscore train, and we will supply this X train and Y train to the model. And then again we have Y test, because we have kept Y test, because after getting all the results, the predicted value, we will compare those predicted value with the actual value which we have stored in case of Y underscore test. Now after this, we have used this Gaussian NB class, and we have created an object of Gaussian NB, that is the Naves based algorithm. The object is NB, and now we have trained the model by using the fit function. So while training the model, I'm sending the X train and Y train part. X train is the data part and Y train is the label part. So we have to send both, because the model would be trained on the data and its corresponding label itself. Now I am using the predict function here to retrieve the output, to predict the value of X underscore test. So X underscore is actually the test data on which we have to test our machine learning algorithm, that is the Naves based algorithm, and we have kept the result in Y underscore predict. Now we have print the both Y underscore test, the actual result, and Y underscore predict, the predicted value. After this, by using the accuracy underscore score function, we have I have find the accuracy, and then after finding the accuracy, I have print the accuracy here. And after this, I have drawn the confusion matrix. Actually, confusion matrix is a way by which we can find out how many data actually which the machine learning algorithm has predicted is true. So here if I talk about in iris dataset, there are three labels. So that is why here it exists three columns and three rows. So here it would be 0, 1, 2, and here it would also be 0, 1, 2. So actually there are 10 data which are 0, and it has also predicted 0. While there are 9 data which are 1, and it has also predicted 1. While there is one data which is actually 1, but the model is predicted as 2. Again here there is one data whose actual value is 2, but the model has predicted 1. And there are 9 such data actually which is true, and the model has also predicted the same. And after that, so yes, sir, this is a different model.
Yes. Okay. So Vinayak, I think you have completed. Yes or no?
Yes, sir.
Okay. So can you explain about data set? What is data set and which data set you have taken?
Yes, sir. I have taken the iris data set.
First of all, go to the data set part.
Okay, sir.
Yes. Tell me which data set you have taken and what is the data set?
Sir, actually data set is the collection of data, sir, on which we train our machine learning model, because machine learning is all about training. Because first we have to train our model, and then only we can we can accept the model to get the output. Sorry, the algorithm to get, to predict to predict certain values. So here, sir, I have taken the iris data set.
Okay, so it is multi-class or binary class?
No, sir, it is multi-class data set.
So actually, what is the difference between multi-class and binary class?
So binary class is a class where only two classes are available. But in case of iris dataset, it is multi-class class, because there are three values which are available in iris 0, 1, and 2. So that is why it is known as multi-class. And in case of binary class, there would be only two values.
Okay. So can you tell me the purpose of using train test split function?
So trend test split function is mainly used to split the data set into two parts, because we are going to split. Look, sir, we are not going to send all the data to the machine learning for training purpose. We just want to send a specific amount of data for training purpose and keep the rest of the data for our testing purpose. So for dividing the data, for splitting the data into train and for splitting the data, basically we use this train test split, sir.
Okay. So can you explain about the Naive-Bayesian theorem or the Naive-Bayesian algorithm, how it works and what is the fundamental basic behind it?
Yes, a Naive-Bayes is a machine learning algorithm which works on the Bayes theorem, which we have learned in case of probability. Actually, sir, it uses the concept of conditional probability to predict the value of any supplied data set or any supplied value, sir.
Okay. Okay. So what is the use of confusion matrix here?
So, as I have mentioned earlier, sir, confusion matrix is basically gives us a diagrammatic representation where we are able to find out that how many data which the machine has predicted true, and how many data the machine has, how many values actually the labels which are being predicted by the machine is true, and how many are false.
Okay. So one more question. Tell me how you can load the data set from sklearn.
Sir, from sklearn I have used here sklearn or data sets, and here, sir, I have actually imported the iris data set. But for loading the data set into a variable, we have to use whatever the name which we have used here. It should be used as a function here if we want to import that particular data set.
Okay, so why you have taken X and Y here?
Where, sir?
Yeah, in second stage.
Okay.
You have
So,
taken
sir,
X and Y.
here actually, sir, I have taken the data part of iris dataset, because iris dataset would contain the dataset with data as well as label, because but we have to split it out. Okay, sir. So for data, for keeping the data, I have taken X, and for keeping the label, actually I have taken Y.
Okay. So one more thing, why you have used fit function and predict function?
So fit function is used to train a model. For training any model, we use fit function in any algorithms which we have learned till now, and predict function